Okay, everyone, today we're going to talk about characteristics of a box and whisker plot. Yesterday you made them. Just remember, when you make them, it doesn't matter how many data points there are, you can make a box and whisker plot. One of the things, if you're just giving the box and whisker plot, you cannot tell how many data points are on here. I started with this one because it says the time spent playing soccer each weekend. Well, there's no way of knowing how many people are on the soccer team. All right. Remember, this is how many minutes. So there's not 100. There's not 100 people. All right. That's just how many minutes that person, whoever that person was, that's how long they played soccer. So make sure that you understand that when you're just looking at a box and whisker plot, there's no way of knowing how many people are on there unless they tell you. So now that we have that under control, now if they do tell us, like this one here, it says a representation of 2,000 SAT scores from area schools. So this is a representation of 2,000 people, all right? And these are their scores. So somebody scored a 720 and somebody scored a 250, all right? Maybe more, maybe there were two or three people, right? So some characteristics. This today, what you're going to learn is the characteristics of a box and whisker plot and what it tells us. So each section, this lower quartile here, in this section right here, is 25% of the data, meaning 25% of the 2,000 people. All right, that means that 500 people scored between 250 and 400. All right, on their SAT. In this section right here, this is 25% of the data. So again, 500 people scored inside this area right here. And then this section here, 25% of the data. Each little section, so 500 people scored between a 500 and a 560, right? And then the last, of course, we got to have 100%. So 25% scored in this section. So 500 people scored in from 560 to 720. I don't know specifically. I just know that their scores were between 560 and 720. So you can ask a lot of questions from this. I can say 50% of the people scored 50% of people scored between a 400 and a 560 because these two sections go together, that's 50%. All right. I can ask the question 75% of the people scored above a 400 because 75% from here to here is 75%. So 75% score between a 400 and a 720. So there's a lot of information here that you can use or answer questions with. All right. Let me go on to the next slide and show one more. So now this says 800 seventh graders weights. So they weighed 800 seventh graders, and this is how their data is represented, right? We can, again, each section is worth 25%. So 25% of seventh graders are between 105, weigh between 105 and 114 pounds. This is 25%. Okay. We can say 50% because these two right here, these two sections is the middle 50%. So that's going to be between 114 and 126 pounds, 50%. This is 25 and this is 25. Okay. So there's a lot of information here that you can gain from, or a lot of data will give you this information that you can answer a lot of questions. If you remember, just a quick point here, remember when we did the skewed right and skewed left, this data would be skewed right because all the data is down here, all right, and that tail goes down here. There's less data up here, all right, so here's where all my data is. 75% of my data is in this region, so this would be considered skewed right because it always goes to where the lower amount of data is. The way I remember it, it's the whale tail. All the data is up here and going this way, all right? That looks like a whale. This will be skewed left, this example. If all the data is up here and it goes down like this, There's the whale tail. The data will be considered skewed right. And that's how I remember it, skewed right and skewed left. So make sure you take this information, rewatch the video if you need to, and then practice today's lesson.